In this lesson, you will learn how to solve quadratic equations using the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is the b squared minus 4ac from the quadratic formula can help you determine if you have two real, one real, or two non-real solutions. A lot of times it's easiest to find the value of the discriminant first and then plug that in to the quadratic formula in order to solve for the solutions. So let's see our first example. Here we have 2x squared plus 3x minus 5 equal to 0. First, identify your a, b, and c. In this problem, a equals 2, b equals 3, and c equals negative 5. You can go ahead and plug everything into the quadratic formula, or like I said, plug in just the b squared minus 4ac. I'm going to go ahead and do it all at once, but feel free to do a piece at a time. So negative b plus or minus the square root b squared minus 4ac all over 2a. Again, working the discriminant will first tell you how many solutions you'll have. So let's do that. B squared minus 4ac, we get 3 squared minus 4 times a, which is 2, times c, which is negative 5. That gives us a positive 49. Because our discriminant is positive, we will be finding two real solutions. As you plug in the discriminant, go ahead and multiply the other parts together as well. So our negative b makes it negative 3, plus or minus, we found the discriminant to be 49. All over 2 times 2, we found that to be 4. Be sure to extend your fraction bar because all of the numerator needs to be over the 2 times a, or in our case, 2 times 2. Simplify the parts that you can. So the square root of 49 is a perfect square. So negative 3 plus or minus the square root of 49 is 7, all over 4. Once you have simplified as far as you can, you'll make your two solutions. So negative 3 minus 7 over 4, and negative 3 plus 7 over 4. Because we had a positive discriminant, we should be finding two real solutions. Negative 3 minus 7 gives us negative 10 divided by 4. That can reduce to negative 5 halves. And negative 3 plus 7 is positive 4 over 4. And again, that can reduce to 1. So our two real solutions are negative 5 halves and positive 1. This can be checked with the graphing calculator, so let's see how to do that now. In the graphing calculator, if you go to y equals and type in the equation you have, replacing the 0 with the y, we have 2x squared plus 3x minus 5. If you view that graph, you should find that it crosses the x-axis at the same place as your solutions. It crosses at negative 5 halves, which is really 2 1/2, so negative 2.5, and at positive 1. So you can check your solutions with the graphing calculator and find that they are the same as the x-intercept. Let's look at another example. Number 2. Here we have x squared minus 6x minus 7 equals 0. Again, start by naming your a, b, and c. A equals 1, b equals negative 6, and c equals negative 7. Let's plug that into the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Be very careful, especially when plugging in negatives, that you use parentheses. Let's find the value of the discriminant first. B squared minus 4AC will tell you how many and what type of solutions you should have. So B squared minus 4AC, that gives us a positive 64. Because our discriminant comes out to be a positive value, we will be finding two real solutions. Let's go ahead and simplify the other parts of the quadratic formula that we can. Negative 1 times negative 6 is positive 6, plus or minus the square root. We just found all of this for the discriminant to be 64. All over 2 times 1 is 2. Go ahead and take the square root of 64. It is a perfect square. So we have 6 plus or minus 8. The square root of 64 is 8. All over 2. Again, extending that fraction bar over under the entire numerator. You could think about this as 2 divided by each of those values, or separate it out and work each of the numerator and then denominator. So we'll have 6 minus 8 divided by 2 and 6 plus 8 divided by 2. 6 minus 8 is negative 2. When you divide that by 2, you get a solution to be at negative 1. And 6 plus 8 is 14 divided by 2 is 7. So our solutions, least to greatest, are negative 1 and 7. We can check this again in our graphing calculator. Going to the y equals, we have x squared minus 6x minus 7. When you view that graph, our x-intercepts are at negative 1 and positive 7. The same places as our solutions when we solve with a quadratic formula. Let's look at another example. Number 3. Here we have 2x squared minus 8x plus 7 equals 0. First identify your a, b, and c. Using the quadratic formula, we could solve for x. So negative b plus or minus the square root b squared minus 4ac all over 2a, always extending that fraction bar so the entire numerator is over the denominator. Let's simplify each part. Negative times negative gives us a positive 8, plus or minus the square root. We'll have to find the value of the discriminant, and then 2 times 2 is 4. So let's find that value of the discriminant. We have negative 8 squared, be sure to use parentheses when squaring a negative, minus 4 times 2 times 7. So our discriminant equals 8. 8 is not a perfect square, so you'll need to simplify that using prime factorization. The prime factors of 8 are 2, 2, and a 2. So we have a pair of 2's that comes outside of the radical as 2, and this 2 will stay inside. So 8 plus or minus 2, the square root of 2, over 4. This problem can be reduced. 8, 2, and 4 are all divisible by 2. So we're going to find 4 plus or minus 1 the square root of 2. So you don't have to write the 1, or you can. Either way is fine. Divide by 2 in the denominator, we get 2. So our solutions are 4 minus the square root of 2 over 2, and 4 plus the square root of 2 over 2. Let's look at one final example. Number 4. Here we have negative 5x squared minus 2x minus 8 equals to 0. We're going to have A equals negative 5, B equals negative 2, and C equals negative 8. Using the quadratic formula, we can solve this equation. So x equals negative b plus or minus the square root of b squared minus 4ac. Being very careful with all those negatives to correctly plug them in. All over 2 times a. Let's simplify. Negative times negative is positive, plus or minus the square root will come back and do our discriminant. Over 2 times negative 5 is negative 10. So let's find our discriminant. We have b squared, so negative 2 squared, again using parentheses with those negatives, minus 4 times negative 5 times negative 8. So the value of our discriminant is negative 156. Because that discriminant is negative, we will be finding 2 non-real solutions. So let's do that now. Taking the square root of a negative does result in imaginary solutions. So let's also take the square root of 156. You'll have to do the prime factors. 2 goes into 156 78 times. 78 divided by 2 is 39. Divide by 3 is 13. And then divide by 13, and that gives us a 1. So we have a pair of 2's that will come outside the radical, leaving everything else as it is, 2 plus or minus over the negative 10. We're just simplifying right now the square root of negative 156. So we had the pair of 2's that come outside the radical, as well as, like we said, the negative makes the imaginary solution, so it also comes outside the radical. The square root of 3 and 13 stay, so multiply them back together. 3 times 13 gives you 39. The last step to simplify this is to divide everything by 2. And also I need my plus or minus. So divide everything by 2. 2 can be divided by 2. This 2 can be divided by 2 as well as negative 10. So 2 divided by 2 is 1, plus or minus 1i, or you can just leave it I, the square root of 39, over negative 5 when you divide by 2. So our solutions, least to greatest, we have 1 minus I, the square root of 39, divided by negative 5, and 1 plus I, the square root of 39, divided by negative 5. Subtracting will be smaller than adding, so those are our solutions in least to greatest order.